Okay.
You don't just subtract what you need.
Yeah, yeah, that's all it is. Yeah, exactly. Let me just go ahead.
I noticed the for the velocity -1, 3 is the
Yeah.
4 is the second.
That's right.
Share the exact
Yeah, yeah. Let me just talk you through the details there. Yeah. So the function, the critical thing it's given is it says the function is known to be differentiable. Right. And when you know it's differentiable, that means that you have this linearity property. That means that, in other words, you have directional linearity. So you can compute directional derivatives by a linear transformation. So when we say the directional derivative with velocity 3, 4 of this function is equal to 7, and we say the directional derivative with velocity 4, 1 is equal to -3, you can rewrite this with a linear transformation, namely the derivative transformation df at your point A times the vector 3, 4 is equal to 7. And that same derivative transformation applied to the vector 4, 1 is equal to -3. So if you want to compute the derivative transformation, now again, same derivative transformation because we're at the same point. If you want to know what does that do to the vector -1, 3, well, you're right to observe that, well, golly, let's see, that vector minus that vector gives me this vector. So I could just rewrite this as df at, well, let's see, this is 3, 4 minus 4, 1. And here's where I apply linearity. This being a linear transformation allows me to rewrite this as the derivative transformation applied to 3, 4 minus the derivative transformation applied to 4, 1. So this is where you use the linearity. You're right, you subtract these vectors, and that allows you to subtract these what are in fact directional derivatives. So it's the linearity, the fact that this function that you're looking at directional derivatives of, the fact that this function is differentiable means that you can do this linearity business. And of course these you already know. Let's see, this one is 7. And this one is -3. So you get 10.
So you don't have to do the whole thing
where you parameterize a line instead of, no, not only do you not have to, but you can't. And that's what's interesting about this problem. You notice I never told you the function f. So if you were to parameterize a function that sort of moves off in the direction of the vector -1, 3, you would never be able to evaluate the function because we're not given any information about what the function looks like in that direction. I mean, we know what the function does when you move in the direction 3, 4. Right, we know it behaves like that in that direction, and it behaves like this in that direction, but we have no directly given about the nature of the function in that direction. So you sort of have to use the linearity here.
I did. I solved for like x and y, like the point.
Yeah.
Or whatever. And because I just did x plus what was it, like 3t and y plus 4t.
Yeah.
And then did that for both of them, and then just combined the equations, and I got 10. Well, is that valid or not?
I'd have to see it. I mean, the fact that you got the right answer makes me think that there's at least some validity to it, but I have to see exactly how you did it to really know if it's fair. I mean, there are certain illegal things that you can do that happen to give you right answers. Well, it's possible. So I'm just not sure exactly what you're telling me here. Do you want to just show me what you did? Or?
Yeah, sure.
Okay. Actually, show me in a second. Let's see, does anybody else have any questions about this? Okay, let me just do one last little quick thing here. It'll take 2 seconds. So remember, the original question was to compute the directional derivative with a certain velocity. What we've done is compute the derivative transformation on that vector. But of course, remember, what derivative transformations compute is, in fact, directional derivatives. So we didn't write this as a directional derivative, but this formula computes directional derivatives. So the thing we're trying to compute is 10. Okay. So, yeah. the thing that makes this problem work, aside from, okay, obviously you have to know that the function is differentiable, but the problem gives information about directional derivatives, and it asks for information about directional derivatives. So the other thing you have to do is realize directional derivatives are computed with linear transformations. And take the given, take the goal, and rewrite those as things about the derivative transformation so that you can use the linearity. Okay, let me stop the recording here.